Oops. Hello. Let me share my. Can you see my screen?
Yes.
Okay, awesome. So I'm just going to like share like this. It's fine. I just want to add about my introduction. I also got my PhD from UTS, so it's my alma mater. So it's great to be back here, and I thanks to ACI for this opportunity. So today I'm going to discuss about a little bit about the PE civil structural exam. It's a vast topic, so I'm just going to give you an introduction about how to start, some basic introduction, some tips and tricks. But if I want to elaborate, like what you have to study almost everything that you have studied so far about structural and not to pass the PE civil structural exam. So when I took the exam, I took the exam at 2021. The syllabus was a little bit different. There was two different section. One was a morning section or a breadth section, and there was the evening section, which is the depth section. So the morning section was general for all the PA civil exam taker. It was like just like the FE exam, a little bit advanced, but it was like a general section where you have to answer about like WRE, transportation, structure, environment, and then geotech, everything a little bit. And then after the morning session, there is the breadth section where you have to uh, take the exam on some specific topic. Like if you are a structural PE, all those that section will be structural. If you are a transport, it will be transport and so on. But from 2021 to 2024 April, they changed the syllabus. So now there is no morning section. There is no breadth section. There is only depth. So if you want to take the structural exam, it will be only structural. If you want to take the transportation exam, it will be only transport. So there is both some advantage and disadvantage. The advantage is you only have to study the structural if you want to take the structural exam. That's obviously like the advantage, and the disadvantage is the question will be only structural, so it will be a little bit different, a little bit difficult. The depth section, and it will be in depth since there is no like general section. Everything will be structural or transport or environment, and the passing rate of structural P is very low. So it will be a little bit difficult, but it's not impossible. If you're serious, you can definitely do it. So let's go through the syllabus first. Uh, the first topic is analysis of structure, loads and load application, and you will get around 12 to 18 questions from this section. So some of you guys like ignored this section, but you see that almost like 12 to 18 questions. I have seen more than 18 questions coming from this section, and this is a pretty general section. Like we thought that we know this, but there is a lot of problem. When the problem arises, we cannot solve it if we don't have experience. So the dead load and live load portion is pretty much everybody knows that, but the construction load is important because we'll get some question from like some mathematical problem from construction load, definitely some mathematical problem from wind load and seismic. You will get some question from wind and seismic. Moving load, you will get this part from ASHTO, because ASHTO deals with the bridge, and in bridge when you design the live load is basically moving load. Then you are definitely going to get some question from snow, rain, and ice. Uh, there might be some question from earth, pressure, and surcharge. Like if there is a buried, let's say there is a buried structure, buried pipe. So how the earth structure, earth pressure, and the surcharge load will come to the pipe. This can be another question. Then there are like the tributary areas and load combination. So there is a lot of uh, this section is mainly mathematical. There will be a lot of mathematical problem, but also there will be a lot of conceptual question. So I'll discuss a little bit more how to tackle this section in the later part of the presentation. Then there is the second section, which is the analysis of structure, forces, and load. So this is basically statics. If you are undergrad or if you are a graduate student, you definitely took the statics course. So you have to study everything from the statics and structural analysis, because you will get the shear force diagram, the bending moment diagram for sure. You're going to get more than one question for like these diagrams, and then they're going to ask you to find the flexural stress or the shear stress of a beam, or a combined stress like those, like sigma is equal to my by I or VQ by IT. You're going to get this question, go get those question for sure. Deflection is another very important part. You'll find a beam where there is like a couple of load, and they will ask for the maximum deflection or deflection of a point. So your basic has to be very, very clear about this statics and structural analysis. There are some special topics like torsion, buckling, thermal deformation. So these are pretty much everything that this section provides, and you will get around 17 to 26 questions from this. So this is also a pretty important section. If you go to the next section, there is a temporary structure section, which is pretty like there will be probably 2 or 3 questions or some conceptual question from this. So if you go through the codes, this section should be easy. And I'm not going to focus on this because only like 5 questions from this section may come. But yeah, you have to make some like you have to practice some problem for the form work, and for the safety you'll get this in the code. The fourth and fifth section are the most important sections. So basically what I say, the fourth section and the fifth section are the same. It is just they're just saying it differently, but they're the same. I'll explain how. The fourth section is design and detail of structures, materials and material properties, where they discuss about the soil classification, especially the phase diagram that you know. All the equation will be given. You just have to know how to use that phase diagram and the soil classification. And then there is concrete and steel, two of the most important thing in the entire exam, steel and concrete. I'll tell you how. These two, the concrete and steel, these are the most important section of the entire PE exam, and most of the question will come from this section. Then there is timber and masonry. So UTA has a timber design course and a masonry design course. If you take to like those courses, the content of those courses are like pretty extensive, and they are good enough for timber and masonry. I'm not saying that you can ignore one of those, but let's say if you study the entire thing and then you don't have time to study either timber or masonry, you can actually leave one of those, because you can see that only 10 to 15 question will come from probably from masonry or timber. There will be 2 or 3 questions. So if you are focused on the other questions really good, if you leave one of that section, that is good enough, like that is fine. But I also at least get some basic ideas about timber and masonry, like some basic like beam design for like the reinforced masonry and unreinforced masonry, and then the stud design for timber, the beam design for timber, like some basic ideas. Then because I've seen that the question from timber and masonry are not very in-depth, they're pretty basic. So if you have a little bit idea, you can answer those. And then there is a material testing procedure, concrete, steel, masonry, timber. These are section 5. And sorry, these are section 4. Now the section 5 is basically section 4. The first is horizontal member, that means beam, slab, diaphragm, strut. So they are either steel or concrete, right? Steel design or concrete design. And or you will find the vertical member, which are like column, bearing wall, shear wall. They are basically concrete or steel. And then there is truss, there is connection, which is steel. Connection, the board, weld, they're basically steel. And then there are shallow foundation and deep foundation and retaining wall, who are concrete. So if you are good with steel and concrete design, you are good with like most of the part of 4 and 5. Now, the exam specification, which is very important. The exam is computer based and it is closed book, but there will be an electrical reference. The NCSS PE civil reference handbook will be given, and all the codes will be given too. So you have to know, like the codes will be given. You don't have to memorize any code. You don't have to memorize any equation, but you have to know where the stuff are there. So you have to be very thorough about the codes. You have to read the codes. You have to know the codes. That's it. The second part is like the exam is basically 9 hours, and there will be 80 question. There will be like both US unit and the international unit. These are basically the important thing. And then if you look at the design standard, the codes, excuse me. Yeah, there are ASHTO, which is bridge design code. There is IBC, AC 716, ACI 318, AISC, AWC NDS, which is for the wood or timber design, and then CFR Title 29, these are for safety, and then TMS, which is for masonry. So out of all of these codes, the most important codes are the ACI and AISC. The ACI is for concrete design and the AISC is for steel design. So you have to know these codes from beginning to end very well, and also the application of the code, how to design the members using the code. If you know ACI and AISC very well, you are going to pass the PE exam, as easy as that. And then the another important two cores are the IBC and ASC 716. You are going to get a lot of conceptual question from IBC and ASC 716, and those if you have to know these scores also, the IBC and ASC 716, for the load combination, for the wind load, earth load, for the safety, and for those stuff. So I will say the four most important codes are the ACI, ASC, IBC, and ASC 716. You have to know these codes. ASHTO, there are some parts which you have to know, like the thing is, if you go to the ASHTO, if you know how to do the girder design, if you know how the live load are calculated, the basic ideas are good enough. You don't have to know the entire code. But yeah, to pass the PE exam, you have to know the ACI, ASC, IBC, and ASC 716. And these codes will be given. Now, let's go some topic by topic. The first, let's discuss about the first topic, which is the analysis of structure and load. Around 12 to 18 question will come from this. And for this question, you have to know IBC and ASC 716. There is another very important thing. A lot of conceptual question will become, not only the mathematical problem. You say if the 80 question is total, maybe there is like 30, 35 conceptual question. So to answer those conceptual questions, you have to know IBC, ASC 716 and the other codes also, not only the like problems. And you will get problems for wind load, seismic load, snow, ice, rain load, impact load, surcharge, and load combination. All of these from ASC 716. So first you have to know the problems, then you have to read through the codes. For example, on the right side of this slide, I gave a wind problem. You see, like this type of problem, this problem has arrived in PE exam previously, PE structural. They give the wind direction and they will ask you what is the wind load per story. So you have to know how to calculate the exposure, how to calculate the topography, and then how to calculate the wind load per story. You have to distribute those load. Seismic, we know Texas doesn't have seismics, but the PE exam, there will be some seismic problem too. So you have to know how to calculate the base shear based of those seismic. You have to know the ASC 716 to know the seismic map and the wind map. So these are very important. You have to know these codes. And also, I have seen a lot of times snow and ice load. These appear to the exam. For example, there is a problem in the load combination. You see there is this frame, and they're asking which load combination may produce uplift at footing B. So there are 4 load combination. Which combination will produce uplift at footing B? Can anyone answer this question? This is a pretty simple one, but this problem actually appeared in one of the PE exam previously. This is pretty simple. Okay, I'll just answer. It's fine. So this is D basically, because the dead load and live load and also the wind load from this direction, they are causing compression at B, right? So they are not causing uplift. If you want to have uplift, then this wind load has to be come from this negative direction. Only that time they will introduce some uplift. So this these load combination will cause uplift. So these are the PE exam will be tricky. It will be like based on what you know, but they will give some tricky question. These are just an example. So you have to practice a lot of problem. That's another thing that I'm saying. You have to buy books, and for problem for AC 716, whenever you have some time, solve that. You have to find problem for IBC, for AISC, and for ACI, and solve those. The second section is analysis of structure, which is force and load. So there will be 17 to 26 question. If you take statics course or structural analysis course, you have to just revise those. That's it. You have to revise the statics and structural analysis course. You will know how to solve this. There will be SFD, BMD, axial diagram. You will definitely find question from this diagram. And then deflection. You'll find question from torsion, buckling, and thermal deformation. And then there will be beam and truss analysis. So for truss, there will be always some truss analysis. There will be a big truss, and they will ask for to find the force in a member. But think about this, like you have 6 minutes to solve every problem, because there is 80 problems and there is like around 8 hours. So there is 6 minutes to solve every problem. If you start solving a truss from beginning, it will take 1 hour to solve one truss. So you have to be very like tricky. Let's say when you'll see there is a truss problem and they want a member force, most of the member will be zero force member. So you don't have to calculate most of the member. You will know that the forces in those members will be zero. I'll teach you a trick. Let's say if two non-collinear members are connected to a joint without any external force, both members are zero force. For example, if you look at this joint, there is two non-collinear members, right? And there is no external force. So both of these members will be zero. Similarly, for these two members, for this joint, this member and this member are two non-collinear, sorry, and there is no external force. So both of these member force will be zero. Again, if there is three members without any external force and two of the members are collinear, then the other member, like the non-collinear member, is zero. For example, if you look at this node, these two members are collinear, right? So this non-collinear member, this will be a zero force member. Same for this node. If you look at this node, these are two non-collinear member. Sorry, yeah, these are two non-collinear member, and that means this member is a zero force, and the force of that two member is equal. So you have to know these tricks. In that case, when like you will see most of the members are zero. So if they ask for one member, you have to just like put the like joint method or the section method in one section, and you will find that member. So it will be less than 6 minutes. You have to know these tricks, and if you like buy a book, a good book which like gives all the problem of PE, there are the tricks there. Then there is the chapter which is the temporary structure, the section. It has only 5 to 8 questions. Basically, you have to know the design of formwork and the construction load. You will find all of this from ACI 716. If you have good idea about ACI 716, you can answer these temporary structure questions. Also, you have to know how to design the formwork or how to design temporary load during construction. You just have to probably solve like some problems, and then you are good with this section. It is not very like big or very important. The next section is very important, the next two section, because if you see this section around 10 to 15 question, the next section is around like 26 to 39 questions. So around 50 question will come from these two sections. You can say around like 40 to 50 questions. And these two sections almost are like the same section. So the first section, there will be 10 to 15 questions. The first is soil classification and properties. All the equations are given there, the phase diagram or like some soil testing, those procedures. If you go to the manual for PE, you will find those equations there. You just have to calculate some problem. You just have to practice some problem. That's it. You don't have to go very extensive about the soil. But then the concrete is very, very important. You have to study concrete from IBC. You have to study the T-beam. You have to study short and slender column, the flexure and shear and torsion, the development length, the design of one-way and two-way slab. And then also you have to study the pre-stressed concrete beam, the pre-tension and post-tension, those. So basically pretty much everything from concrete. Like also you have to study the foundation design, shallow foundation, the deep foundation, and then also the retaining wall. So everything is in IBC. If you know these pictures, your life is beautiful. So you can see that this is like the continuous beam from IBC. These are the T-beam, and this is one of the interaction diagram for column design. Then you have to know the steel, timber, masonry, and material testing. So after concrete, the most important thing is the steel. For the steel, AISC, you have to know that the design of tension member, like this plate and those bolt. And then you have to know the compression member design, like the beams. And then you have to know the base plate design, the flexural member like beams. Then you have to design the sorry, the compression member is column. I misspoke. Compression member, the column, you have to know those like buckling, how to design the column for buckling, those buckling load. You can see this K, theoretical K for design, where we know that we have to use this K factor for designing the buckled column. You have to know the design of anchor, design the connection, the bolt, the weld, basically everything about AISC. And then just I mentioned timber NDS, masonry TMS. You can even like ignore one of that if you don't have enough time. And then material testing. You have to know how the material testing is done. If you just read through any material testing book, that's good enough. And then the final section, which is the design and detail of structure, there will be 26 to 39 question. This is basically the previous section. That's it. Because in this section, you have to know the design of beam, column, slab, diaphragm, strut, bearing wall, shear wall, which is from either ACI or AISC. Then you have to know the design of composite construction, which is from AISC. You have to know like those steel beam and on top of the concrete deck, which is pretty common here in US. I think some of the UTA buildings are also these composite constructions, especially the new constructions one. So you have to know how to do the composite construction calculation, how to calculate those start and those things. And also you have to know the calculation of connection, which is bolt, weld, and the bearing anchor, which is from AISC, because most of the connections are steel. Then you have to know about the footing, slab, and mat, which are from ACI, the shallow foundation. And then also the deep foundation, pier, pile, caisson, shaft, which are from ACI. And then you have to know how to design the retaining wall. These are also from ACI. So you can see that if you know ACI and AISC, you can answer at least 50 questions from the PE. You have to know the ACI and AISC from top to bottom. Some tricks. AISC and ACI has a lot of design aid, especially AISC. It has a lot of table for design aid, AISC. And then at the end part of the AISC, there is hand calculation, like how to calculate manually for those beam and column. But you have to know how to use those table, because in the PE exam, you will get a lot of questions from those table, those design aid. Because if you start doing hand calculation, it will take you forever, but you don't have time. So you have to know how to read those table from ACI and AISC. These are very, very important. And also real life design, when you design something, the engineers, they always use those design aids. So you have to know ACI and AISC very, very well. That's what I'm telling again and again. But when you start preparing, you will know that why I'm telling this again and again. So basically, this is an introduction, but as you know, you have to study everything that you have studied so far and more. The PE structural exam is you have to have some advanced knowledge about steel and concrete and those structural analysis to pass the PE structural exam. I'm not going to like sugarcoat it. It's very difficult exam to pass. But if you are really determined and study, if you have a study plan, if you spend some time, you are definitely going to pass the exam. So you have to have a thorough knowledge about the codes, especially the ACI, AISC, IBC, and ASC 716. You have to know the load and load paths. You have to know statics and structural analysis. And finally, concrete and steel design. If you have very good idea about this, you are going to pass the PE exam. But you have to work a little bit hard. So yeah, this was all about today. This was just an introduction. There is a lot to discuss about P, but I hope this gives you a heads up when you start this one. So I'll just take some question. If you have any question, I think we have like 4 or 5 minutes to take some questions. If you have any question, just you can ask me.
I have a question, Ikram. So,
Yeah, sure.
all the reference materials are those provided on screen, or we can take the printed copies as well?
So previously it was not CBT, but like it was, you have to take those courses. So when I go to the exam, I took 2 luggage. And I'm not joking. I
Okay.
took 2 luggage because ACI, AISC, IBC, AC 716, TMS, and then NDS. These are big courses. But now there was an advantage of that because I could like mark those courses, right? because those are my codes. I know those in details. But now they give everything on screen. You cannot take anything. They are going to give that code on screen. So now you have to know that in which section which part belongs. That's why you like nowadays you have to know the codes better than previously. So yeah, this was a very good question. You cannot take anything with you, but everything will be provided, but you have to know the codes. Like if you are going through the if you let's say you find a problem and then you started digging the codes, there will be 6 7 codes and you'll be overwhelmed. Like, what's going on? Where is it? You'll not find it. Like it will be very bad. So you have to know the codes. Like you have to know, yeah, exactly. At that section, that question comes from that section. So you immediately go to that code and open that section, and then you will find it. That's how to tackle the problem. Yeah.
Great.
I have another question about the
Mhm,
time. Like
mhm,
you said, it's a 9 hour long exam. So
mhm.
is it gonna be a at stretch or a segmentized like 3 hours, 3 hours, 3 hours, or 9 hour at stretch?
So there is a thing. The exam is actually 8 hours. 9 hours
Okay.
is 1 hour, where probably in 15 or 20 minutes they're going to give you some tutorial how to go through the course, how to do the stuff, and there is like around another 40 minutes or 30 minutes where you can take a break. So that break you have when you take that break, your exam will be paused. You will go outside, you will eat or drink for half an hour. You will use the restroom, and then after half an hour, you will come back and the exam will resume. So that break you can take it at any time. Like if you want to take it after 1 hour, you can take it. If you can take it after 4 hour, you can take it. So they're saying like it's optional. So normally what people do after 4 hour, they just take the break. And after 4 hour they just take the break for half an hour. They clear their brain and come back.
Okay.
Hi, Efaz. I wanted to ask, did you also took any preparation courses or classes?
So I did not take any courses, but my company, I was working with a company at that time, TES. They provided material. I asked for the material and they provided materials for me. But the thing is, yeah, there are plenty of good materials out there. School of P is one of them. School of P is very good. You can buy their material. Like you don't have to take the course. You can buy their material only, or even you can take the course. But buying materials is good enough for graduate students. That's I found. School of P is very good. EET is very good. There is PPI, which is very good. So yeah, you can buy just any of the material and then start the preparation, because the material will be what will happen. The material will have like everything in a orderly fashion. So you don't have to dig all the books and stuff. You just open the code and then the material will say what to do. So you can, yeah, buy the material from EET or PPI or for School of PE. If you are working in a company, your company is going to reimburse those for sure if you buy the material. So that's the one good thing if you like join a company, or then do the thing. Or if you find some like previous PE exam in, like who have take the PE exam, who have the material, you can ask the material to them. Yeah.
Can you just share the links to the materials so that we can share it to the members of ACI?
Yeah, I'll send you.
Okay.
I'll send you the email, and then you can forward the email to the members. Yeah, sure.
Okay.
Yeah.
Okay. So if we do not have any question from other guys, then we will jump to Balaram for FE exam. Thanks, Dr. Ifaz, for
Thank
your
you. Thank you.
expert insight. You can remain on the meeting, or if you have some work, important work, you can leave. But we will be very welcoming you to be remain on the meeting. So Balaram, I will be leaving you the floor to continue for your FE insight.
Sure. Thank you, Abhijit.
Dr. Ifas, can you just close your screen so that Balaram can share if he wants? Thank you.
Yeah, thank you. Thank you to Dr. Ikram. We shared a share company a few years back, and we also share a same research group. So he senior, and thank you very much for the P initiation. I still have to take the P exam, so that was very useful for me as well. So I'll quickly walk through the FE exam. how's the exam format, how the questions are distributed in the different topics, and how can you access the materials, and what's the procedure to register for the exam. Um, Share my screen quickly. I have a few presentation slides, and after that, if time permits, I'll go and share some of the web pages of um, these things. Can you guys see my screen?
Yes.
Okay.
Can you just bring your mic close to your mouth because it's kind of suppressed?
Okay, got it.
Yeah, thank you.
So once again, thank you everyone for joining. And I'll be going through the FE exam information session. So I'll have introduction, importance, eligibility, registration, exam format, topics, result, resources, engineering training, and I'll also show my references. So FE stands for Fundamentals of Engineering. I have highlighted the word fundamentals because basically that's what this exam is about. It's going to test your fundamental knowledge on the civil engineering. So this is the first step in the process of becoming a licensed PE. One of the requirement for sitting for a PE exam is to have an EIT certification. There are some waivers regarding EIT certification for PE exam, but still getting your FE is the easiest path in my own opinion. Same as PE exam, it is also administered by NCES throughout the year. It's a computer-based exam, and and you have to take it in an approved Pearson testing centers. You cannot take your exam anywhere else unless they do have some exceptions for certain accommodations, but the center still needs to be approved by NCES. So the importance of FE exam, as I said, it's a gateway to professional engineering licensor, and then after taking your FE exam and once you passed it, you can apply for engineering training certificate. It increases your professional credibility and recognition, which in return increase your job opportunities, especially for the uh, early career civil engineering jobs or the entry level jobs. Having an EIT certification or passing an FE is considered a very significant credibility. uh, so if you have a better credibility, you have a chance for better salary. And during the process of preparation for FA exam, you have to review all the materials from your bachelor's coursework. So that means one more revision, you'll have more, you'll uh, review all the concepts, theories, practical knowledges, and having an EIT certification or being certified in any manner is also significantly good for your personal confidence during your interviews. The eligibility for FE exam is an undergraduate student within 2 full semesters, not including the summer semesters of graduating. So basically, if you are in your senior year of your bachelor's, that's the equivalent to the fourth year, you can take an FE exam. So, but for that, your engineering program has to be EAC or AVET accredited. If you are a graduate student who is enrolled in master's or PhD engineering program, and if you haven't taken your FE exam, you can still take it. There is some if you are not actively an student, then you can still uh, take the FE exam, but the only requirement is you need to have a bachelor's degree in engineering or in related science field. So the exams is limited one attempt per testing window and no more than 3 attempts in a 12-month period. So the first window is January to March, and then subsequently it goes there are 4 windows in a year. So starting from January, it's gonna be 4 windows. So the process to register for an exam is you have to go to NCES website, you have to create your account, and there you can select date, time, and testing center. Currently the exam fee is $225. You can reschedule exam fee, but the rescheduling fee is $50. So please be careful when you are selecting your date for the FE exam. make sure you have enough time for preparations so that you don't have to reschedule it multiple times, because I've seen so many people rescheduling it two times, two, three, four times. So if you reschedule it for four times or five times, that's already a price for another FA exam. So please be careful on your date when you select your date for the FA exam. Exam is basically it's computer format, computer based. There will be 110 questions. There will be two sessions divided into 55 questions each. So the total time is 6 hours. There will be non-disclosure agreement and tutorial, which will be for 10 minutes. And then the exam is actually 5 hours and 20 minutes. You'll have a scheduled break after the first session of 25 minutes. You can choose not to take it, but it's wise always to take a break for 25 minutes. You don't have to take the break for whole 25 minutes. If you want to get back early, you can get back early as well. But you can take a break up to 25 minutes, go out, uh, use restroom, get refreshed. If you want to have some snacks, you can have snacks, and then start fresh again. You will also have options for both SI units and USCS units. So whichever unit is more comfortable for you, you can go for that unit system. Exam format again, there will be a reference handbook on screen. It's a searchable PDF. I'll show you the full document after this presentation, but being used to with that reference handbook, as Ikram also mentioned before, it's the same thing. It's almost 500-page document that includes all the reference materials for civil engineering, chemical engineering, materials engineering, and uh, all seven um, disciplines of FE exam. So you need to know exactly where to look for what page number, what section for the material you or for the reference you want to have it. Uh, Similar to PE exam, if you go there and try to find out the equations or the references during the exam period, and if you do not know where those materials are on the handbook, then it's going to be a lot of time will be killed on that thing, and you may not be able to attempt all the 110 questions. It's a searchable PDF, so if you know the exact section, you can go and search. Uh, the questions are mostly multiple choice format, but there will also be some questions which have multiple correct options. There might be point and click, drag and drop, fill in the blank. On the right side, if you see it, this is one of the section of the reference handbook. That's for structural design, which it has given the load combinations for LRFT. If you do not know exactly where this section lies, and if you want to see the load combinations, then it will take a lot of time for you to find the reference you want, which may kill your time. Topics, as I said, this is the fundamentals of engineering exam. So everything during your bachelor's, starting from the very first semester to the very last semester, will be included in here. You have starting with mathematics and statistics, 8 to 12 questions, ethics 4 to 6, economics 5 to 8, statics 8 to 12, dynamics 4 to 6, mechanics of materials 7 to 11 questions, materials 5 to 8, fluid mechanics 6 to 9, surveying 6 to 9, water resources and environmental engineering 10 to 15 questions, structural engineering 10 to 15 questions, geotechnical engineering 10 to 15 questions. So mostly the core engineering courses have a higher number of questions, like the water resources, environmental, structural, geotech, and also the mathematics. Two other topics, transportation engineering and construction engineering. These two topics are also have a very significant number of questions in there. If you go to NCES website, you can see exam specifications where um, these topics are further given in detail, um, what will be included within these topics, because these topics themselves are very, very vast. So to give you an idea about the depth of the content, If you go to NCES website, you can see the exam specifications. I'll show you the specification in a bit. After that, the result is 7 to 10 days after exam. You'll get an notification on your email whether saying you passed it or you failed it. If you passed it, it will just show as if you have passed the FE Civil exam. But if you failed it, the NCES will provide you a diagnostic report showing the comparison of your performance with the average performance of the test takers during that testing period. But one thing that uh, it gets a little bit tricky is NCES doesn't have any fixed mark to pass the exam. So you don't know how many questions you have to get it correct to pass it. So that's why it gets a little bit difficult to understand. But this is how the system works. So they have a scaled score system for the results. Uh, but you cannot say I'll get if I get 50% questions right, I'll pass, or 60% questions right, I'll pass. Somewhere in online, if you look at people's opinion, they say usually if you get 60 to 70% questions right, you have a chance to pass it. But that's not the official statement from NCES. So it's better we go for the best all 110 questions. If you want to get some references or the resources, definitely the reference handbook from NCES. That's the most important thing. You need to know where the things are that you're gonna need. You have practice exams from NCES that are paid. It's $50 per exam. You have a lot of YouTube videos. One of the YouTube videos that I have seen being used by a lot of my friends as well is from Mark Matson. So it has 16 videos playlist for FE Civil. One video is around 1 to 2 hours, so it's gonna be lengthy content. But um, that's one of the YouTube channel that has been referred by so many of the test takers. There are review manuals as well. You can buy them, or some of the manuals are available for free in the PDF format. There are tons of free online materials. Here at UTA as well, I have seen in recent years during the summer semesters, there has been FE preparation classes. So if you are interested, you can to take those FE uh, preparation classes as well. Uh, the YouTube is Mark Matson. So if you search for Mark Matson, FE, you should be able to see it. Okay. So yes, the UT has also the FE preparation sessions. The price, it is not for free. It's But the price is comparatively low from what I have seen in the market, and especially if you're undergraduate student, the preparation sessions also had incentives. If you pass the exam, then your fees will be refunded back to you. So that was the incentive for mostly for undergraduate students given by UTA. After passing the exam, your next step is to apply for engineering training license. The engineering training license and FE exams are two separate things. Often I have seen people using it as interchangeable thing, but no, FE exam is a separate, and EIT certification is a separate procedure. FE exam is the first step to get your EIT certification. For that, you have to apply for EIT at Texas Board of Professional Engineers and Land Surveyors. They will require your official transcript for the highest engineering or related science degree. They will also require your FE exam verification. And once you get your EIT certification, your data will be on the public domain. So once you apply for the job in companies, and if you give your EIT license number to the company, then they can come to EIT roster in Texas PLS website and then verify your certification. So most of the things, it these are the references that I used. If you have any questions, I can take the questions now. But at the same time, I'll quickly go and show you the NCS website. So this is the NCS website for FE exam. This is where you create your account and then register for the examination. This is the FE civil exam specification, which looks like this. So this one will give you more details on to what depth and what topics you have to be prepared for the FE exam. This is the reference handbook. You can download it once you have make an NCS account. You can download it for free. As you can see, it's 502 pages. It has everything, including chemical engineering and for civil engineering. This is how it looks. So you you need to be um, really uh, thorough on this reference handbook if you want to be a very efficient test taker for FE. These are the mm, practice exams that I mentioned before. That's in the NCS system, but these are paid. This is my NCS account. This is Texas Board of Professional Engineers and Land Surveyors website. This is where you have where you will be applying for EIT after passing the FE exam. So this is how the application looks like. I think it has a fee of $25. Once you send an application, they will assign a reviewer for your application, and then the application review process takes anywhere from 1 to 3 months. So it's a lengthy process, um, but it's not as tough as PE. But it is very important if you are starting a career, especially in structural engineering. I have seen EIT, uh, graduate structural engineers with EIT in very good demand for the early career civil engineering jobs. So yeah, that is all from my side. If you guys have any questions, please uh, feel free to ask.
I think we don't have any questions. Maybe, or everyone just passed the FE. The students are looking for PE exam.
Okay.
Okay, if someone has any questions in future, they can forward the questions to us so that we can share it with our experts or any other experts that we know, and try to answer those questions based on whatever topic they want to know about. And the links for the materials and this recorded video will be uploaded on YouTube, our YouTube channel, and the links will be provided using our email list. So thank you for joining today's session, both of you, Dr. Ifaz and Balaram, for your very expert opinions and the beautiful presentations that you gave. That is a start.